All right, let's go ahead and get started. And we're going to talk now about converting between fractions and decimals. And in a lot of ways, we're going to discover that, well, in fact, there's no real difference between fractions and decimals. They're just different forms of the same numbers. So first of all, let's talk about converting a fraction into a decimal. And in order to convert a fraction into a decimal, what we're going to do is we're just going to do the division. And when we do this, what we're going to do is we're going to divide that top number by the bottom number. Always that. So we divide the numerator by the denominator. So let's go ahead and get started. Let's start off with something fairly simple, like 3/4. What we're going to do here is we're going to just take that 3 and we're going to divide it by 4. Now 4 doesn't go into 3. So what we're going to do is, of course, we put a decimal point after our whole number, and we're going to start adding on some trailing zeros. And we're going to go ahead and proceed on with our division. 4 doesn't go into 3, but it would go into 30. 4 would go into 30. Looks like 7 times. 7 times 4 is 28. 30 minus 28 is going to be 2. We can bring down this other 0. 4 will go into 20. 5 times. 5 times 4 is 20. And I've got a remainder of 0, so I can stop. So I can say that 3/4 is equal to this 0.75. Just by doing this division. Now, we're going to run into a couple different kinds of questions with these. First of all, this one is nice, and I chose this one because it's fairly familiar. And if you think about it, it would make sense. How much money is 3/4 in, American currency? 3/4 is 75 cents, or 75 hundredths of a dollar. Well, let's take a look at something maybe a little bit more complex. Let's do something like 3/11. This one's going to be a little tougher, but let's see what happens. Again, we're taking that top number, which still is 3 this time, and we're dividing it by 11. But we're going to go ahead and tack on some trailing zeros and see what happens. 11 doesn't go into 3, but it would go into 30. And it looks like it'll go in there 2 times. 2 times 11 is going to be 22. And and of course, 30 minus 22 is going to be 8. Let's bring down my next place value. 11 would go into 80. Well, it looks like it'll go in there 7 times. 7 times 11 is going to be 77. Oh, here's another 3. When I bring this down, I notice that 11 goes into 30. Oh, it's 2 times again. 2 times 11 is going to be 22. Hey, there's that 8. And now I've got an 80. 11 go into 80. Well, it looks like 7 times again. 7 times 11 is going to be 77. And here I've got this 3. Notice that we've got a repeating pattern of decimals. A repeating pattern of remainders. And what that means is that no matter what would happen, if I were to keep going, I would just end up with 0.2727272727, and I would continue to have 2s and 7s. Well, notice that it's just this 2 and 7 that's always repeating. So if I'm writing this out, I can't write out an infinite number of decimal places, but what I can say is, well, I have a special notation for a repeating decimal, and that is placing a bar over the digits that repeat. So this bar notation places a bar over digits that repeat. So, yeah, that's fairly straightforward. Well, what will sometimes happen then is we're going to want some of these fractions in this bar notation. Well, another thing that could happen is you could be asked to write something like, say we've got like 7/12, but we're going to say as a decimal to the thousandth place. Well, when I do this division, let's see what happens. I would have to, again, do this division. Say we've got 7 divided by 12. And if I know I need it to a thousandth place, I'm going to want to round to that thousandth place. So I'm going to want at least one more place value. So not just our tenths, hundredths, or thousandths, but a 10,000ths place. And let's see what happens. 12 would go into 70. I want to say about 5 times, because 5 times 12 is going to be 60. I've got 10 left over. We'll bring down the 0. 12 will go into 100, maybe 8 times, because 8 times 12 is going to be 96. Okay, well, 100 minus 96 is going to be 4. Well, 12 will go into 40. Looks like 3 times. 3 times 12 is going to be 36. And now notice I've got another 4 again, so I'm going to end up with this repeating pattern where 12 will go into 40 3 times. We've got 36, and I will continue to have that repeating pattern. So at this point, it's going to repeat. Which means that if I were writing this out as in bar notation, it would be 0.583, or basically 3 bar. I only need to put it over this one digit that repeats. But if I were continuing this on, notice my instructions say as a decimal to the thousandth place, I need to round to this place value. So as a decimal to the thousandth place, this is just going to be 0.583. And if you're using a calculator, you can test this out. Say 2/3. Notice that, because your calculator only has, anywhere from 8 to 10 place values on it, if you say 2/3, 2/3 is 0.6 repeating. And if you'll look at your calculator, you'll notice that that last digit that it displays is a 7. It rounds to that last place value. Well, same thing's happening here. We're just rounding. Here we just have we're only saying that we're going to our thousandths place. All right. We've done this in one direction. Let's go ahead and turn this around and do this in the other direction. And decimals to fractions is actually really, really simple. If we've got a decimal we have a lot of information. So say we've got something like I'm going to say 0.45. What we're going to do is we're going to write this decimal number over the last place value. So 0.45, this would be 45, and notice that our place value here is our hundredths. This is going to be 45 1/100ths. Now we can reduce And because our denominator is always going to be a power of 10, we can only reduce by factors of 2 or 5. We don't have to do a lot of searching for things that will go into both the top and bottom. Here I can divide the top and bottom both by 5. So when I divide the top by 5, I would end up with 9. When I divide the bottom by 5, I'd end up with a 20. So this is going to be 9/20ths. Let's do that again. And say we've got something like, I don't know, how about 0.06? Well, in this case, we've got 6/100ths. And this time I can reduce by a factor of 2. When I reduce by a factor of 2, I'm going to have, well, I'm dividing top and bottom by 2, so this is going to turn into a 3. And 100 divided by 2 is going to be 50. So this is going to be 3/50ths. All right. Hopefully this makes sense. If you've got any questions, shoot me a message, and I'll see you in the next video.